Number 48 here is a problem that I like a lot. They're asking you to find all the extreme values here, just the max and min, which means absolute max and min of this function here, y equals x plus sine of x on the interval from 0 to 2 pi. Now, you guys do not need to know this, but the graph of this thing is pretty cool. You guys know that the graph of sine of x is just a normal wave that looks something like this. So that's that term. The graph of y equals x is, of course, just this dotted line going up here like this. The sum of these two, you guys, kind of takes this, I can't move it right now, kind of takes that sine wave, and instead of running it along the x-axis like this, it kind of runs it up this way here. So this graph is going to kind of do something like that. It's like a sine wave that follows the line y equals x, and it goes up and down, although the overall trend is certainly up. So finding the max and min, I don't think is going to be an easy thing just to look at here and go, oh yeah, obviously the answer is 5. So we need to approach this a little bit more analytically. Where can extreme values occur? Only two places, critical points and endpoints. We've got our two endpoints here. I'll deal with those in a minute, but for now, let's find our derivative. dy dx is going to equal, that's going to be a 1, and the derivative of sine of x is cosine of x. We want to know, where is this derivative either equal to 0, and I think we'll find some values there, or where is it undefined? Well, 1 and cosine of x are both defined for all real numbers, and their sum will be defined for all real numbers. So this derivative will never be undefined. So what are we looking for here, guys? I'm going to bring that 1 to the other side. I want to know, where is cosine of x equal to negative 1? Now, there's actually an infinite number of answers to that question, but lucky for us, we've got a limited domain here from 0 to 2 pi. So I'm really hoping you guys could look at that and tell me that the answer here is just pi. If you need to, and our friends in pre-calc are doing something like this right now, there's your unit circle. Cosine, everybody, is our x value, and we want to know, where is that x value equal to negative 1? Well, if this is a unit circle here, guys, with a radius equal to 1, there is only one spot on this circle where your x coordinate is negative 1, and that is right here at the point negative 1, 0. And of course, that angle is pi. And lucky for us, pi is inside that domain right there from 0 to 2 pi. So that's the one and only critical point that we have to worry about. Okay, so we've identified all of our critical points. There was only one, and our two endpoints right up here. So at this point, guys, it is time. I'm going to switch color to purple here, and we're going to evaluate the original function at all three potential spots where a max or min could occur. Y equals y of 0, that's our left endpoint. We're going to evaluate y of pi, that's our one critical point, and then our right endpoint is 2 pi, so we will evaluate the original function there as well. All right, let's plug in the 0. That's a 0 plus 0, which gets us a 0. Awesome. Putting in a pi, we've got a pi right here. Nothing's going to happen with that. And sine of pi, that is your y coordinate at this point here, which is 0. So pi plus 0 is going to get us a pi right there. And now when we plug in the 2 pi, it's tempting to think that 2 pi is going to get you the same result as 0 because 0 and 2 pi radians are the same angle. You'll get the same value right here, but this term right here that we're adding, that value will change. So this one becomes a 2 pi plus a 0 right there, and we just end up with 2 pi. This isn't as interesting as I hoped it would be. So basically, guys, as we move a little further along from left to right, in what they're showing us right here, your y values just keep getting bigger. So again, they were asking for the max and min values of the function on this interval. They're asking for absolute. So the absolute maximum is your highest y value, which is 2 pi here. So there is, I'm sorry, they didn't use the word absolute, so I'm not going to either, but that's what it is. That's your absolute max, and then 0 is going to be your absolute minimum that we come up with for this interval. So that should be our answer there for problem number 48. I thought it would have been a more interesting problem if they kind of gave us an interval there where this thing was starting to come back down just a little bit. But anyway, it didn't, and that's what we came up with. So there's 48.